Hello, everyone. Can everyone see my screen now? Hopefully. Is everyone there? Are there any replies? Good. So I was talking to myself for the last 5 minutes, and I'm going to say the same things, and this is hilarious. So, a couple of things. I need to rewind a bit and go back to my original mental state. So, number one, interfaces. What I've done, I've made this layout that contains the Redshift render view. And a couple of things that people may not know is that if you press Command or Control on this little thing, you can hide a panel, you can collapse it, and then just click here and it will open up again. So this gives you access when you don't have much real estate very quickly. Command or Control, close it, then just hover over here. It tells you which one it is and just click and open it. The other thing, which I'm going to use later on, is if I have another panel, which I don't want to go and look for it when I'm in. I realized when you do this in Windows, something else disappears. Excellent. So I'm finding out all these new things about Windows. So if I want to have this panel, I don't want to go and find it every time in the menu. You can just drag it on top of this line and it becomes a tab. So now I have this, I can collapse the panel. So I have a very quick way of adjusting my real estate, my monitor real estate. Now, the other thing is render settings, and this is something that comes up sometimes. I've created my own little preset here, but I'm going to tell you what you need to do. It's good to make a preset. So usually you have your standard layout here, standard renderer. So I have an RTX 5000. It has 16 gigs of RAM. That's a difference between the 2080, and I think it's the equivalent speed of the 2080. And number one, because I have enough RAM, I can actually set the bucket size to the maximum. And this gives me a small speed boost because the card is able to work with a larger chunk of data in each bucket. So it doesn't go back and forth in memory and send stuff. If you have less RAM, you make this smaller, and this will not overload. It will allow your memory. If you have a card that has less memory, you can use a smaller bucket size. The other thing which only applies to RTX cards is the enable optics RT, and this just gives you another speed boost. And the last thing, which is an experimental feature now in the branch version 3 branch of Redshift, which is the one I'm using the automatic sampling. Now, there's a fantastic video. It's about an hour that shows without automatic sampling how you can maximize your speed and all that. So I'm not going to say many things about it. But if you have an RTX, just do this, and if you have version 3, just enable this, and it will speed up. And you have control over your quality just by using this number here. So the other thing is I set this to 2048, which is my maximum samples, and I set this to 256, which is my minimum samples. And this number now biases. The smaller the number, the more it biases towards the maximum value. The larger the number, it biases towards the minimum value. And this is a threshold, right? Now, if you don't have version 3 and you have version 2, there's a quick little rule that says that you set your min and maximum samples are going to take care of your motion blur and your anti-aliasing. And this needs to be divisible by this exactly. And the other thing is you turn on all the overrides and you set them to 2048 and you set this to 1024. That's it. 256, 1024, and all the sampling overrides to 2048, and then you use this number again. So it's very similar to the automatic sampling. Anyway, I'm going to go with automatic sampling and leave everything else the same. And I always turn on brute force because why not, right? GPU is fast. My previous render was physical render, so I've got a speed boost anyway. So these are the settings I've got in this little preset. Once you set it up, you right-click and you say Save Preset, you give it a name, and then you have it here available every single time. You can get rid of everything else. So let's talk about volumes, how to set up a simple volume using a volume builder and a cube to begin. The cube is my favorite object. So number one, and this is a rule, don't use SDFs, use FOGs. And SDF doesn't describe the interior of an object, the volume of the object. It describes a volume around the surface. So watch my tutorials on Cineversity if you want to find out more details. So fog. And the fog volume by default generates values from 0 to 1, where 0 is the surface of the object. So Command and Control this. So 0 is right here at the edges where the surface is, and everything else is a 1. So this is full of ones. Now let's go and light this up and see how we can render it. You click on this and it won't do anything because there are a couple of things we need to do. Number one, we need to add a light. So let's go and add an area light for now, and let's move it back. And you can see still nothing happens. The next thing you need to do is tell the light, or any light you want to participate in any volumetric effect, fog, environment volume, or anything else, a VDB you found on the internet and so forth. You need to go to the volume tab and you need to increase the contribution scale to a value. Depending on what you're doing, you may need an extremely low value, but we're going to use a default of 1. Now we still need one more thing, and that is to go and create a redshift volume material. And we need to drag it on the volume, and then we need to link it up. So go to the RS volume node and go over here, and you need to go to the channels and define where the values of the volumetric data is coming from. So you can drag this here, or you can go here and find all your volume builders. And now here you go. We have something which looks terribly ugly. And the reason for that is, as I told you before, this is a block of ones, right? It's a full cube full of ones, and there's some artifacting here, but that's easy to fix. You need, in order to have a nice, soft, smooth volume, to tell whatever you have in here to have a maximum voxel fall off. This means that although it's going to have a 0 voxel value at the edges or where your surface is, it's going to gradiate towards the middle where it's going to become 1 at the point which is furthest away from the surface. So the minute I do this, we get this. Now this looks like a nice white sponge, and that's basically the idea. You know, a fog is a sponge is nothing more than dense fog. So we've managed to light this up. How do we control how it is? So let's bring up the material again. Let's very quickly, because you can find all these details on the internet. Scattering is the diffusion, the equivalent of diffusion, how it reacts to lights. And absorption is how it, the alpha channel, the transparency. And the general rule, which I discovered from Merck, is that it's better to change the values and keep them the same in tandem. So 0.1, this will react less to light, and 0.1, it will make it more transparent. So you can see now, light has the ability to penetrate more inside your little sponge. And you can go and make this very, very small, and you can create all sorts of interesting effects with this. Now, for example, now if I grow this, I'm controlling the transparency of my sponge. Now we're going to do a few more things here just to make it a bit more fun. Now we have the ability to colorize this as well, but I'm going to show you in a second. I have my notes next to me over here. Just want to make sure I'm following the script. So let's do the following thing. Let's talk about the values for now, so we understand a bit better what's going on. And for that, I'm going to turn this off, and I'm going to add a dome light. So we have light coming up from everywhere. I'm going to tell this dome light not to be visible in the background. And now I need to control its contribution scale. With volumes, you may need to balance out the contribution scale, the light intensity, the absorption, the scattering. It is a more complex construct. But anyway, this looks interesting. Looks like some weird foam. And what I'm going to do is I'm going to go to the volume builder and add a field. So let's go and add a linear field and drag it in here. And what I'm going to do, you can see immediately this becomes a gradient, right? And I'm going to set this to apply its little operation on the objects below, on that little cube. But I'm not going to use null mode. I'm actually going to use multiply. So because my gradient on one side is 0 and the other one is 1, you can see that I'm creating a gradation of this, and I can control this gradient now with my field. Now, the other good thing I can do with this, let me get rid of that. is I can go here and add, for example, a spherical field. Let's add it here. Let's do the same thing as before, set it to objects below and multiply. But what I can do to this, and let me make it smaller. What I can do to this is change the remapping. I can change the minimum value. Now, because it's multiplied, that means that where we have the value 100%, it's going to give us whatever was underneath it. And here we have only 10% of that value. But I can increase this value to, let's say, 1,000%. So I'm creating a more, let's say, dense or a volume that has a higher value. So essentially, what's happening in here is that now I'm getting a value of 10 instead of a value of 1 because I'm multiplying it 10 times. And this way you can go around adding all sorts of different fields to create interesting effects in your volumes. Now, let's see. The last thing I like to do is add a noise field because it's fun. And again, you can already see some things going on here. I'm going to multiply it. I didn't multiply the sphere. That's why it was so odd. But you get the idea. I trust you understand what I'm talking about. I'm going to set this to a nice Voronoi, nice little circles. Let's make this 300%. And in the remapping, you can do all sorts of interesting things to sort of make this look, have a certain look. You can change the inner offset. You can do other things. You can go here and change the curve, reset it, and sort of contrast this noise to make the holes more prominent. So you can make a decaying something, whatever, cheese, a decaying sponge, and all that. So you can see that as far as the shape is concerned, you have a lot of control using fields on how you're going to make your volume look and behave. And of course, don't forget the voxel size makes a difference in terms of resolution. So now you can see the circles, now you can't, right? Now you see them, now you don't. So, and of course, if it's a very low, it takes a couple of seconds to calculate. But already you can see that it creates the opportunity for very interesting effects. Now let's go and look at the color for a moment. Now, when you're creating volumes here, unfortunately, you cannot create color data. You can only read color where it says color channel if your VDB has embedded color information. And that is for VDBs that come from other third-party software. So if we want to colorize, we actually need to remap the values we have here using this ramp. So let's go and do that. Let's go here and open up this, and let's go quickly and load our little rainbow. And there you go. You're remapping your zeros over here, your ones over here, and everything else in between. And that allows you to do very interesting effects. So let's go and cut into this and see what's happening inside. So I will get a nice cube. I'm going to move it out of the way. I'm going to rotate it. I'm going to make it taller, bring it out. And I'm going to say, oh, I'll put it here and subtract it. So get this and subtract it. Now, here's where there's a minor little issue, which I think it's already fixed and it's going to be available in the next update. There's a little technical issue, and all the negative numbers in the volume, because subtracting creates negative voxels, are calculated as positives. All you have to do is go and add a fog curve on top, and this will it will actually get rid of those negative numbers because it clamps all the negatives, but it clamps the positives as well. So use it with caution. So now we can see inside and we can see what's going on. Now, don't forget that I've remapped this to be something extremely ridiculous. So there you go. I'm going to make it a bit better. And there you go. So this is now the color inside the volume. So that is an idea how you can actually create something that is visually interesting. And you can use your standard Cinema 4D tools without any external tools. So if you add to this some sort of surface, an object which you've created, and it's got some surface animation and so forth, you can make clouds, you can make cheese. I think cheese is a very good idea if you give it a single color. So you can make Emmental. Fantastic. Let me see now on my list. So I've done all that. And yes, okay. The last thing is emission. And emission is quite interesting. It's a separate channel. Let me go and reset this to default. So we have our little cheese. Now, the way currently the volumes work, you can have an emissive channel, but it's going to be the whole volume builder. If you want to create some sort of emission in here, you have to create a separate volume builder and just add some emission. But for now, you can always go and create some sort of emissive parameters here, and you can make this glow, I guess. There you go. So you use the same principles, but it's going to be self-illuminating, right? So I don't think I need to go into the emission too much. I don't know if anyone maybe has a question later on. We may be able to address it. So yeah, create a second volume builder, follow the same rules, fog and whatnot, apply an emission parameter, and they will interact, especially if you have global illumination active. So let's see. Yep. So let's go and do some particles, because what I like to do is use Cinema 4D Vanilla as much as I can. And in this particular case, we're going to start for something very simple, and then we're going to recreate this in the remaining time we have. I think this is going to finish much earlier than I expected. So nonetheless, let's continue.
I'm sure they'll have questions for you.
Good. Like that. So number one, the simplest way to create particles with several limitations is to use a standard particle emitter. And this will create some particles. But in order for you to get these particles and render them, I'm putting 10,000. One thing I just need to say, because a lot of people forget about it, you need to align these, editor and renderer, so you can see the same number. Some people forget to change this, and then they render in the picture viewer, and the picture viewer has 100 instead of 10,000 particles. And because you can see a lot of particles in a viewport, it's not evident why it's not rendering as much. So just remember to sort of synchronize these two. And in order for us to render particles, we actually need to go to the Redshift tags and add Redshift object tag, and go to the particles tab and just tell it what we want it to render. And the other thing is, because usually things out of the box are optimized for speed, but nothing really looks good. And all you need to do here is add a dome light, and then it looks much better. So again, get rid of the background. So now we have a bunch of particles. And the problem with standard particle, if you're doing something quite simple, or if you're going to use it as an emitter for a cloner to emit clones using multi-instances, it's all nice and dandy. The problem with standard particles is that we don't have control over things like age and color and all that interesting stuff. So my favorite way to go and work with thinking particles in general is to use P matter waves. So let's begin with a sphere with 20 segments, make it editable. And I like to, sort of make things nice and neat and and I'm going to add an espresso tag, right? Please don't stop watching this the stream, right? This is going to be very simple. And just go over here and type.
They're not intimidated of espresso anymore.
Okay.
They've grown stronger.
Hopefully. So the P matter waves is the easiest and extremely powerful way using a single node to generate particles. And all you have to do is take an object or a selection of an object and just drag it in here, and now you have particles. That's it. You don't have to set up any P storms or anything like that. Now, the other thing I like to do is go to my thinking particle settings. Again, it's over here, settings. And in my settings, I change my ticks to dots. It's slightly faster. That's all I'm doing. I'm going to use this later on to drag some stuff here and there. And now we can go to this, the settings of the P matter waves. And let's give it a shot of, I don't know, 1,000 per frame. So here are particles that are generated. There you go. Nice. You just close this so we can see the particles. It's not that bad, okay? I mean, you can't generate easily hundreds of millions of polygons, of particles, but it's still quite good. So let's see, after you create this, you leave this as it is. And if you want to pass any parameters, as I'm going to show you, we're going to use things called p-pass nodes. Very simple to control particles that way. So let's go and fix a few things with the speeds and all that. They've got a life cycle of 90. I'm going to set this life cycle to 30 frames, and I'm going to give it 25% variation. I'm going to put the speed to something like 20, and a slight variation, 25%. It's moved down here. This is how you control everything. I'm going to leave the size at 10, distance, direction, and all that. Now, just in case you want to get into thinking particles, it's an old technology, but it's still very powerful. The p-matter waves allows you to use textures, lights, or textures and lights in order to control all these parameters. You can shine lights on this, and it will only emit from where the light is shining and all that. There's a massive amount of control you can have. So the second thing is, I want to add some sort of turbulence, because this is very linear. You can see everything just goes that way, and I don't like that. And we're going to use a wind. So the wind node, the P wind, everything starts with a P. I'm going to refrain from saying P. In order to pass any data to any node, you use a p-pass. So pass, use a p-pass. And you can do this constantly, like p-pass controls something, p-pass controls something. You don't have to do all these, but it's easier to read your graph after this. So I'm going to tell these to be affected by the wind, and the wind needs an object to get some sort of direction. So you can call a null wind, or it can be any object that has a matrix. And if I drag this in here, you will see we get the that little gizmo. I'm going to make it spherical and set some parameters here that seem to work for me. So the wind now is blowing. You can see it's accelerating particles. It's blowing in a radial manner, and the gizmo changed. And I'm going to get some turbulence in here, like 600 turbulence. Let me set the strength to 0 for now, so you can see the turbulence happening. Look at that, nice little turbulence. And the way you control how fine the turbulence is going to be by changing the structure size. The bigger the number, the bigger the sways. The smaller the number, the smaller the sways. So there you go. So now we have this interesting little thing. And this is out of the box stuff. So our wind is done. Let's go and see how we can render this, and then we'll continue doing some more stuff in thinking particles. So if I render this, you won't see anything, because again, I need to go and add my tag to the particles, but there are no particles here. Which is the object that holds the particles? Well, that object exists in a separate context. So you need to get a TP geometry. This is what reads whatever groups you have to do whatever you want. You can have 10 different groups of thinking particles, each one driving a cloner. So you can do all sorts of stuff. And on this, we need to drag whatever group, and that's the all. So all particles are going to be affected by this. Fantastic. And now I can go and add my tag over here. So Redshift, object, points. And when I press play, you're going to see the particles. So we have several types of particle visualizations here. We have our point instances, we have sphere instances, and so forth. And we can change the scale over here. Now, I am going to change the scale in the thinking particle context, but you can see that already we have some particles that are being generated. So let's begin by making this 0.1, right? So we have these little marbles here. And when you're previewing your particles, you can pause this, because then you have the data coming in and out, and just press play. We're going to bake the particles later on. So my objective for this is I want the particles to do the following things. Number one, I want them to get smaller as they get older. And the age of the particle is defined by the parameter here, the life, right? The life is when they're going to die. The minute they're born, they're created. That's the beginning of their life. And whenever they die, which is 30 frames plus or minus 25%, is the minute they pass away. Blessed they be. But within that, let's say, time frame, the age is that number which we're interested in. Now, the easiest way, there are many ways to get the age. The easiest way to get it is to use the p-scale. And this is where I say, my name is scale, p-scale. So p-scale. So p-scale. This p-scale needs a particle input. I'm not going to use this. I'm just going to copy and paste this. Just again, as I told you before, I just want to have separate, let's say, groups so I can see what's going on. Now, the p-scale itself has this parameter, which is off, scale over age. So what's going to happen now, it's going to do the opposite as far as I remember. So if I let these grow a bit, so the particle simulation is moving, I'm going to turn this on. And you can see they're getting smaller. So what I'm going to do is remove this, and I'm going to rewind, turn this off, press play very quickly, turn it on. And now we have a scale that exists over the lifetime. They begin at their maximum size, which is defined by this scale here. That's the original. So size, and that I've multiplied it by 0.1. So it's 10 times smaller. I can play with these numbers any way I want. And they're getting smaller as they get older. Now, the good thing with this is that now the scale itself provides me for each particle with a normalized value from 0 to 1, which is their color now. So their color is white when they are born and dark when they die. Now, I'm not driving the color per se, but I'm driving a parameter that can be expressed in a color, as you can see here. So it's a value 0 when they're born, 1 when they're born, and 0 when they die. And I'm going to actually hijack that to define my color. So again, another p-pass. And I need to get that scale value. And I need to get it. So you need a p-get data. I'm going to read from this particle the scale. And this scale here is now a value for each particle that provides me with a number from 0 to 1, depending on which part of their life they are. So I'm around 0.54, for example, because I'm going to live at least 100 years. So if you get do the math, whatever. So now I need to set the color of this. So I need to set something. So set data. What am I setting? This particle. Which part of the particle? The color. And put the scale in the color. So now what we have here, you will see that the next time I generate the particles, now don't forget, the reason this is not updating is that these particles are already alive. They don't know what changes I've made. Particle systems are a linear system. They're not deterministic. They calculate. So I need to rewind, press play again, so the particles are born and generated with these parameters. Now you're going to see that they're going to get darker as they get older. So we have that gradation happening over the particles. And there you go. You can see that smaller ones are darker and the other ones are lighter. Oh, this is so cool. Look at that. I can do this all day. Okay, sorry. This all the time, by the way. I don't know what it says about me. That's all I have to do with the particles. So we just use the p-pass to inform another node about what we're doing. And we're saying, after this is generated, we set a wind, which introduces some turbulence. We scale them, introducing the scaling over age. And we use that scaling parameter to drive the color. So how do I use this data now in the Redshift context? Well, it's not very difficult. We are going to go and we're going to create a Redshift. It always freezes for a second when it goes to material presets. And I'm going to go materials and particle. Now, this is just a quick way of making a normal material and adding user data. So I'm just going to show you how to do that without that, so you know exactly what it's doing. Materials, standard Redshift material. Go here and type user. And we need the color user data. And the color user data comes from which attribute? A particle color. If I put this into my, let's say, diffuse color, and I'm going to leave these nice and shiny, so the diffuse color now has that. We get, well, the same because it read the same data. But because now this exists, well, I have to apply it as well. Matthias, anyone that said apply the material in the chat, please send him a t-shirt.
Yeah, they didn't do that.
Oh my! No one's paying attention, right? No one's paying.
There's definitely having other issues, but they're hanging on though. They're doing well.
Okay, so I'm in my Redshift material now. Okay, and I'm getting this data, which pretty much is represented by this graph from the p-scale, right? Just imagine that. And because we can use a ramp to remap colors, I can now intercept this 0 to 1 value and drive it using a ramp. And what I'm going to use, my favorite ramp, full colors. So now we have colors, and these colors are determined by the age of the particle. So up to this point, we've created a sphere. We've emitted using p-matter waves, added a very simple setup. I mean, you can screen grab this and, screen grab it. Okay, or watch the recorded presentation and add the particle geometry. And this is it. This is literally a 45-second setup for you to start doing particles. But now we have more interesting stuff to do. What I want to do here is that just before these particles pass away, I want to colorize them and make them emit. Not colorize them. I want them to emit some light. So I'm going to use the same data. But because I want to be able to scrub along and see what's happening, you can't scrub with particles. Let's go and cache these particles. The way to cache thinking particles is using Alembic. So you select your TP geometry. Do not use Baker's Alembic. You're going to select this, or if you have more of those generators, you're going to go to the export. You're going to go to Alembic, and you're going to set your scene duration. You're going to go to your Alembic over here, and let's type a unique name. Literally, unique name. Ooh, with a typo. Just this makes it extremely unique. So I know how to spell unique. So it's exporting now. And one thing I didn't show, which I should, so export Alembic. Make sure that this particles is activated, nothing else. We do not want the particles to come in as geometry. We just need the particles, right? That's it. And all the data is going to be saved. So now that I've created that, don't forget, go disable your Espresso if you want to keep it in the same scene. If you want to open it, just to make sure that it's correct, unique name, and just press OK here. And you'll see that now we have all the particles with their color. So all the data is here for you to use, and it's live. So let me close this document. Let's go back here, turn off your particle geometry. We don't need it anymore. Go to the Espresso node and turn it off, and merge in your unique particles. Copy. And now we have a live view of our particles. Okay. Now, it's not too shabby. I mean, the number of particles, you can find them here. What do we have? We have around 25, 30,000 or something like that. You could make a million and a half particles and let it, save it to an Alembic, let it do that for 5-10 minutes. And you can have an enormous amount of particles playing in very good speeds in your viewport with this method, right? Go push your luck before, well, save before you do that, but go try it. It's good to stress test your software. Anyhow, I digress. So now let's go and add that secondary aspect, that little emission I want to do. So we're going to use the same data. I'm going to use another ramp. So copy paste this. I'm going to reset this, and I'm going to go to my Redshift material overall, which includes the emission. And let's go to the emission, drag it here, and I'm going to drive the emission over here. Now, don't forget to set this to at least 1. I'm setting it to 10. So at least 1. Let's turn this on. You'll see now we get this huge, again, I'm moving everything and all my notes are disappearing. Windows are funny. So let's go and play with the ramp and see what comes out over here. So I'm going to move this over here and start playing with the ramp to find out. So this is the beginning of the life. this is the end of the life. So you can go and very tightly add a few knots to make a specific particle age group behave in a very specific way. So you can go and do it right before the end. And of course, you can use your 2 key to zoom in here and your 1 key to pan around, just like with the viewport. So you can go in really, really fine and do some nice little changes. There you go. And I'm going to set this something like a bluish, glowish thingy-madoodle. Okay. So now we have the little emissions going on as well. Fantastic. So this is the colorization part and all that. So let's see now how we can make this look much better by actually using some of that visible light we created. I know this is stuck here, but yeah, it's going to go away if I select something else. So I'm going to light this. And I always like to use HDR panoramas, and the content browser has a few interesting ones. So just go here and type HDR and press enter, and all you have to do is just drag it here in the path. So let's get this that has a bit of contrast, see how this changes our lighting. There you go, we get a bit of contrast. We're going to add some lights, so that's going to be fine. So go back here, and let's add a couple of area lights. And I'm going to do my own, the lighting I did earlier for my face. I'm going to represent it. So I created a null. I'm going to call null. And let's go and add a target tag and target it. It just makes it easier for me to control it. Now, if I do this and select this, this is going to change because by default, it renders whatever view we have. Set this to perspective, so it will keep the perspective view. But then select this and move it out of the way. Always create a camera in your 3D view so you have a reference, a visual reference where you're viewing it from, because otherwise you won't know where your lights are in relation to what you're doing. So I'm going to pull this out of the frame quite a bit, and I'm going to set this to be a nice, let's say, reddish color. There you go. Just get some warmth in there. It's going to come, the warmth. And I'm going to make a copy of this, pull it to the right, a bit to the back, and let's set this to nice and a bluish tint. So it's not bad, but I'm still not very happy with what I'm getting here, because I need to fill the background and I want to do it with a volumetric. In order to make lights generate volumetric effects, we need to add what's called a redshift environment. This immediately, you don't need to touch it. All you have to do is go to your lights and increase the contribution. Now, if I put 1 now, it's going to be, oh, that's a lot of volume. Remember that all you have to do is just go a smidge, click there and click your up arrow. And a couple of thousandths are going to be enough for you to get some atmospheric volumetric effect. Now, a couple of things, again, you can find them in tutorials, a few very quick things, how much the light scatters in your scene, so you can grow this and it will scatter a lot, as you can see. And what else? Let me just reset this to default. Attenuation is, let's say, how dense your medium is, and phase basically biases the volume towards the camera on this side, or towards, sorry, the camera on this side or the background on this side. So if it's far away this way or close to the camera, I think that's a 0. The 0 is middle, and then we have far away and close. Anyhow, I'm going to leave this at a 0. And now you can control the contribution. Even the size of the light is going to allow you to have a very specific effect. And of course, you can change the color and all that. I like to control my volumetric light just from the lights themselves. So maybe saturate it a bit more. There you go. When we have the typical, let's make it a bit cooler. There you go. So that's how you would go and do some lighting. Backlight wouldn't hurt if you want to do that, some sort of rim light to catch some nice little reflections. And of course, make sure that you have your intensity, your light intensity, as low as you need it to create your atmosphere, whatever you're creating. Now, the last thing I'm going to talk about is rendering, because it's nice to be able to render this with motion blur, right? Because now, let's go and see how this is going to render. I'm going to go here. I'm going to go, oops, see? That was something I was saying in the beginning, but I was talking to myself before everything went dark. I always forget, because this gives me feedback from Redshift, I always forget that the standard renderer is the default. So if I render this looks really odd, right? It makes you scratch your head a few times. So you need to set this to Redshift. I've got my own little preset. There we go. So delete this, and now I have my nice little preset. Let's render this over here. Excellent. Now, in order to achieve the motion blur needs to be added in this tag, and it's the following. It's not this motion blur, it's the motion vector. When it comes to particle, use the motion vector. So if I render this now, it should render with motion blur if I go and enable it over here. So let's go basic, motion blur, and enable it. And hopefully I won't look silly now, because it's going to render with motion blur. There you go. I don't look silly. I never do. So this looks much more interesting. Now we're going to add a few more things to make this look a beautiful 5 seconds with motion blur and all that. Yeah, I don't know. This makes me happy and depressed at the same time. It's so wonderful in 5 seconds to get a near high definition, beautiful image. Just give me a second. I need to contemplate that. Okay, so let's go and add a few more things, which I love about Redshift. Let's go to the camera now. And what I want to do is focus right here in the middle. Now, the easiest way to focus your camera is to use something that's here, the null. Remember, we have that null. If I drag it in my cameras, so let me, first of all, activate it, get my camera, drag this null in the focus object, in the object tab of the camera, immediately it will focus there. So if I move the null, it will move the lights and the camera focus. And I'm going to go to my camera. Don't forget, if I try and render this now, I'm going to get the motion blur and all that, but I won't get any effects that I'm going to apply to the camera. I'm going to do this because it catches a lot of people. And the trick is, you shouldn't put this in perspective, because perspective is using the default camera of Cinema 4D. It's using the default camera, whereas you need to set it to the actual camera you have here, whatever the name is. So I'm going to show you how this catches a lot of people. I'm going to go to the Redshift tags and get the Redshift camera, and of course I'm going to add some bloom. I'm going to bring this down because I know I have quite intense emission, and I'm going to get a lot of light. The bloom is going to come from the areas of high emission. So if I double click here, I can go to my ramp and to this and say, I'm going to make this 30, just to give it a bit more oomph. So let's go back here and let's go and add bokeh, a depth of field, which is magnificent. And I'm going to get depth of field as well. Let's see if I go close, if I get this. I'm getting nice depth of field. I'm getting all these nice little effects. I think I overdid it with the bloom. Yeah, forgive me.
Can you really overdo it with bloom? I don't think so. I think they support it.
I agree. There you go. Just a little bit. And because I increased the emission intensity, now I can go to a higher threshold, because if you put the threshold down here, it just checks out contrast, right? If I put it close to 0, it's actually going to make everything bloomy. So let's go, I think 5 is a good number. There you go. So we get this nice little thing. We have our depth of field. What else? If you want to increase your depth of field, I wouldn't touch these to begin with. Not bloom. Where are we? Here we are. Bokeh. Don't touch these yet. If you're going for a more, let's say, real field, just go to the camera and lower your widen your aperture, lower the f-stop, and you can go really crazy with this. You can see now, get these extreme bokehs and all that. And this would be something very small if we were peeking with the camera into something very small. So you can use the size, your f-stop, to make something look bigger or smaller. So the higher the f-stop, this is a big construct, like with big little marbles. This now is a very small object we're very close to. Okay, so you can use these tricks to portray scale. So let's click on this and see the quality. I don't believe this. Like 7 seconds. Anyway, I digress again. Just can't help myself, all right? Just forgive me, people of the internets. So we've added our little bloomy thingies. We've added our bokeh thingies. Let's go and see how long this takes to render. I mean, it's so fast to render that I could even let it render while we're talking, but I'm not going to do that. But you can see now we have an image which is beautiful. I'm going to make it even more beautiful by lowering. I'm actually going to make this 1. I don't want this much bokeh. I'm going to render this, and the only control you need to make this render more clear is to go here and go to the unified sampling and change this number. The lower this number, the better the quality. But I mean, it depends on what you're doing. You can get away with this. And this is the Beauty Pass. This, you know, no post effects or anything like that. It's got everything you need, and it renders in approximately 6 seconds per frame. I can't imagine how this is going to render on a couple of 3090s and all that. I'm already being greedy. You know, it's a couple of weeks since I got an actual, you know, professional GPU that can do Redshift, and already
I'm greedy on the renderers. You want all the cards now. Give me. You want a render farm of cards.
Yeah. If anyone is listening from NVIDIA, yeah. Or 430.
Send him a rack. He needs a rack.
Only 2. I only need 2 3090s. So yeah, I don't. Do I have anything? Oh yeah. Very quickly, I just want to show that if you want to add, there's an amazing tutorial on YouTube by Merk, M-E-R-K, and he's showing how to use pre-made VDBs saved from all sorts of different softwares. And let me go and show you a couple of the samples I've downloaded here. So got some mid-air explosion, for example. These are VDBs that were downloaded from the Embergen website, ready-made. So if you want to populate your scenes, and it's just one material here, right? It's literally a very simple.
Just a gradient.
Yeah, it's in the emission. That's where the gradient. And yeah, I just used Cinema 4D's default heat, nothing else.
Classic German flag.
Yeah, I'm using the temperature channel. So these VDBs have more channels that burn, density, fuel, solid, and temperature, and all that. And you use these with different parameters, so you can create, you know, colorize this any way you want. But you can go to the Embergen website and download some free VDB samples and just play around to get a feel for volumes. And you can even, I guess, repurpose some of these just by changing a gradient. You can make this look like some sort of sci-fi weird sort of explosion. Just make sure that this one is always black when you're in emission. And let's do this, and there you go. So this is some sort of weird, I don't know, Avengers explosion. Does that fit in the Avengers universe? Am I owed?
I'm sure Ultron could do something with that.
There you go. So am I owed anything now because I showed this fantastic sort of soapy blue explosion? No, I didn't think so. And yeah, there's a bunch of these available. Dust devils, like for creating tornadoes and building implosions and gasoline explosions. Every destruction imaginable is available. Look at these beautiful things.
And those are all with Embergen, just on their website?
Yeah, they have, I think there are 6 or 7. These are the ones. And if you want to load these, there are 2 ways of loading them, by the way. One is to go to the Redshift objects and use the Redshift volume, by which you just point to the VDB you want to load, and then you apply volume material and you do whatever you want. Or you can use our own loader. So you go to the volumes and you use the volume loader. You load that and it will give you all the grids. And again, you connect it here. So I've done this using both methods, and both methods work fine. There's a slight discrepancy in the way they render, and I'm in discussions with the developer to see if it's something on the Cinema 4D side or on the Redshift side, or it's so small that we won't even deal with it. But anyhow, that is my little presentation on volumes and Redshift, and I hope that you learned 3 things today. And yeah, that's pretty much it. I'm open for any possible questions. Oh my God, I made it 2 minutes before 5:30. I'm so happy.
You've done an amazing job, brother. This was man, so much stuff. But we do have questions. I'm gonna toss in that Embergen link for you folks who want to download this and try out what Noseman just showed. So VDB downloads. So check these out.
Yeah, you can even buy they if you want to go for really professional stuff. There are companies that sell amazing collections of explosions. So you can literally kit bash your way into volumetrics and explosions and stuff like that. You can even that's why look search on YouTube Merc, and he's got one where he's actually using a cloner to clone some of these, and you can make motion graphics using explosions. Now, isn't that a nice way to close 2020? Huh?
Yeah, and I guess if you change it into Alembic as well, right? Could you convert these to Alembic files?
Oh yeah. So you can't save volumetric information Alembic files. What you can do is mesh these things. So well, since we're here, I don't know if my screen is still being
yeah, we can jump back to your screen if you got something for us.
Okay, so you can go to your loader, so volume loader, and let's go and load one of these buggers. So let's go to boop, where am I? Let me pull this on the side. I don't want anyone to see things they shouldn't. So let's go here and presentation, volumes. Downloaded volumes. Let me just bring in the gasoline explosion. Now, this is how it looks. This is the VDB sequence holds one state per frame. So you just open this, and now we have all 3 grids. Let's go with a density, and if you advance this, now this is a typical representation of the volume. So if I render this, it won't render in Cinema 4D, but I can put this under a mesher. So go volume mesher, and I can mesh it. Now we have, I mean, this is the magic of this whole thing. What you're seeing here is a mesh representation of an explosion. So imagine if you have 30 or 40 of these, if your friends make them in Thinking Particles or Embergen or any other software, you buy some and so forth, how much stuff, organic stuff you can do. This can be actually, right, here's an idea for you. You can use this to create a bubble splash into water if instead of rendering it using volumes or something, you render it, oh, come on, type 90 here. I'm going to make a big cube. I'm going to put it here. Let's put some glass. We've got Redshift. We can do whatever we want. I forgot about that. So let's go and do this quickly. I don't even know if it's going to work, but the idea that's going to be fun. Okay, so we have these 2 nested objects, the cube, and inside we have that little bugger. So I'm going to go and pull this up. I need to make sure, where does it begin? It begins from the top. There you go. So I'm going to move it up because I want to make something that looks like something splashing into water, something invisible. So if you're making an invisible man, there you go. And I'm actually going to create a Redshift material and make this material glass. And that's good enough. I'm going to apply this material to both these people things. and I'm going to render this, and I'm going to put a, let's see, an air dome light, right? And let's put something in the dome light. Go to browser again, my favorite forest, and exclude it from background. Let's see if this is going to work, because I need to make sure my normals are correct. Make this editable, because normals, Redshift is not very forgiving with normals as much as Cinema 4D is. And in order for nested dielectrics to work properly, you need to have the proper normals. So how do I can't reverse this, but you can see now that we're creating sort of a splash into water. It's just rendering. I've got this. There you go. So look at that. So I'm using a volume, but I'm, instead of taking advantage of this in a volumetric context, I'm actually using it in a mesh context to create an abstract sort of thing. In this particular case, something falling in water and so forth. So there are so many different ways and so many different things you can do with volumes. Okay, enough with the watery stuff, but you get the idea nonetheless, that you can mesh it, you can combine these different volumes. You can say, I want the density from this one, I want the flames from this one, and so we have, one has flames, but they're not very different, but then you can, I don't know, subtract one from the other, move it a bit to the side and subtract it over here. Sorry, you can drop them into other volume builders, right? In other volume builders, and then you can use this to create a bunch of things. I can take these two and subtract them. So now I have a volume, which is a product by a subtraction of the two. I'm doing booleans on these two, and then I can go and mesh this one. So let's mesh this one. So now I have a totally different volume. So even with this one, which you can download for free, I don't know if you're allowed to use it or anything like that, but that's a different story. You can have an infinite number of different variations by combining them either as volumes or as meshes and so forth. And that's all I have to say. You can put my beautiful face back on the screen for everyone to see.
And we are back. All right. Let's see here. So much. I think it's. I won't say it's overwhelming. I think it's very inspiring. It's a lot to process, but it's a lot of good stuff.
And Twitter is the best way to ask me questions, because anything that I find interesting, I'll probably do something like a tutorial or something like that. So yeah, ask people. I think it's a good platform. It's got many, but it's a good platform for spreading this kind of, a question you ask actually is very enlightening for someone, because they may have not thought about applying a method that generated that question. So it is your sort of your chance to with asking a question, to get people to say, oh, I didn't know, I didn't think of this. And it's sort of inspiring to other people as well.
Yeah, it's awesome. And our friends and the makers of Ambergen jumped into chat, so that's really cool. And so I'm going to try and chat them up, because I know a lot of people are interested in the workflow. I know it's something I've been looking at personally for a while, and a lot of the Cinema users have been enjoying this. So thanks for that. And yeah, we'll chat some more, see if we can get some more cool stuff going together. So let's see here what else we have on the docket. So there was a number of questions, brother. Let me dive in and see what we got. So somebody was wondering why you didn't switch to Icasa Heat. Are you okay, Noseman?
Yeah, it was just today I thought I'd do something different. And I'm really happy you caught that, because that means that people really love this whole thing.
They were concerned. They're just wondering if you were okay. Not using Icasa. All right. So he's fine. You just wanted to make sure you were listening. He'll do that sometimes. All right. So someone wants to know, what's your favorite part of Redshift?
The renderer.
Speed?
Everything about it. I like everything about Redshift. It's very you can parameterize everything. That's the fact that it's. I think it's totally biased. That's the whole thing. It reminds me. It's the closest thing to standard renderer, because there are renderers out there which, it's the minute you press the render button, they look beautiful, but the control is much less. Because I'm a geek and I love to sort of solve things and put things together, I love the fact that you have so much control over the samples per object, per light, per material, it's right there at the limit of the amount of stuff I can play with and control things to the point I want to.
Perfect for control freaks.
Yeah. And solving problems. You always, when a tool allows you control, because at the end of the day, if you want it to be beautiful, you just save a render setting and add a couple of post effects like a bloom, bokeh, and all that. You can add them as a post effect, it's not a post effect per se. It gets applied normally, but after you do the render. And you can have that preset, and every time you make something, you click a button and it looks good. But I like to do things from scratch. It's something I enjoy, the process and all that. And, I love that about Redshift. And of course, it's blazingly fast. The Cinema 4D developer is Greek. He's a friend of mine. He's a great dude that lives in one of the most beautiful islands in the Eastern Aegean Sea. So, yeah, there's not about it. And one of the founders of Redshift, Panos Zongalas, he's Greek as well. So, it's a very...
You're in good company.
You're
in good company.
Beautiful people. You can talk to them.
So here's another question. Someone's diving into particles. How would you make the particles collide?
There is collision nodes in thinking particles. It does slow down things to a certain degree, but you can always, depending on what exact effect you want to achieve, you may be able to achieve it other ways. We have to remember that it's thinking particles is over 20 years old, and still, you can do relatively good stuff. I could have pushed this to 1.5 million particles and make everything really nice and tight and small and beautiful. It will take a few minutes for you to save it as an Alembic. But if you're doing huge stuff, we can't compare the speeds with dedicated tools like XParticles and all that, all right? But you have it already. It's in your installation, and you can use it. And as I think I've shown today, it doesn't take that much if you're creating that sort of medium complexity stuff. So
it looked really good very quickly.
Yeah, Tim Clapham, I think, has some old thinking particle tutorials. On Cineversity, I'm sure you find something. I haven't checked it out, to be honest with you. You can go on my YouTube channel and check out. I've done some tinkering with thinking particles. And if you do have questions, because with the new technologies now introduced in Cinema 4D and the node system and all that, everything we know is going to be redone in the new system at some particular point. So maybe it's a good idea, even if you are a bit afraid of nodes, just to get in there to start getting an idea of how you can get more control over something. I believe for any professional that wants to branch out to either different software or even different compositors, Nuke is node-based. Understanding generally how a node-based system works. Unreal, of all things. After I dabbled with Cinema 4D's nodes for a few months, working with the developers and Maxon to, for feedback and my tutorials and all that, I started working in Blueprint, which I had never touched in Unreal Engine. And it took me 5 minutes to get on board.
Nice.
They're so different. They're very different, but the fundamental concepts can be carried from one system to the other. And understanding the data flow, that's the biggest thing. A stacked material system or a stacked object system like we have in Cinema 4D, the object manager and the standard material and all that. And After Effects, it's a stacked system. Understanding how the data flows, getting your mind to realize that what happens top to bottom in Photoshop, After Effects, and Cinema 4D starts flowing from left to right and can branch out. The minute you understand this, it's like a
It translates.
And you have a sort of, you understand more about what you have been doing in the stack systems all these years. It's an enlightening moment. So I would say start from the very basics, thinking particles or a bit of espresso, because you can do some really interesting stuff with it. Hopefully today was a very small illustration of that.
Yeah. Someone made a comment here. Noseman is the type of guy to make a sandwich by creating the bread itself first. That's
I make my own bread.
He does make his own bread.
Oh yeah. If you need any recipes, if you want videos about how to cook, because I'm the house cook. I cook for the family, and I enjoy it very much. And I make my own breads, and I make my own. But I picked it up from my mum. She was from Asia Minor, Turkey, so they have a very strong tradition with food. My mum makes yogurts. She makes her own cheese and all that. When you're retired, you have enough time, and you live in Greece. That's what you do.
So they were right.
Yeah, I do make my
spot on, Keyframe. All right, so let's. Speaking of baking, there's another question. Speaking of baking, why export as Alembic instead of bake Alembic?
Oh, because the bake as Alembic will do the same thing, but you can't select the particle setting. So it's optimized for meshes. So the history behind that is that they wanted a faster way for you to be able to bake down the meshes you were creating with the volume builder and the fields, right? Those amazing things we've seen in the show reels. And they added a subset of all the parameters you get in the export. They added them on a right click. So you right click, bake as Alembic. And that allows you to make iterations on your models very fast, because it takes clicks, go file, export as Alembic, click the buttons, click OK. They just wanted to speed this up to allow people to just right click, select, bake as Alembic and delete, and get the mesh in your file and continue working on it. When it comes to particles, that was never a special requirement, because you will only use it once. You won't build upon your baked particles. So that's why the settings are hard-coded in your bake as Alembic, let's say, object manager shortcut, and it's not the ideal way. It won't save the particles.
So you get a little bit more customization when you
it's not optimized.
When you export.
It's only optimized for meshes. It doesn't mean you can't. No, I don't think it saves the particles at all. But anyway.
But that's how it's optimized, though. It's optimized for meshes. If you're going to export, then you get more customization. And Noseman likes customization. Noseman approves of more customization.
I approve that message,
yes. All right. Someone's wondering, can you use this or similar method to generate VDBs?
Can you generate? Of course. You can use any particle input in any volume builder to create stuff. If you go back when volumes were originally introduced, there were a few presentations, including mine. I think it was SIGGRAPH, where we showed how to use. You can just drag a standard particle emitter in your volume builder, and it will create the volume. You can drag a group. So if you want to drag thinking particles in your volume builder, you don't drag the thinking particles generator from the object manager. You have to go to your thinking particle settings and drag that little name that said group, and that's what you drag in there.
Drag the group into the volume builder.
It's the same one you drag into MoGraph. If you have a cloner set to object, drag the thinking particle group inside there, and that will give you access to clone objects on your thinking particles.
Very cool. Somebody's wondering if the particle setup can be affected by dynamics, and
no. Thinking particles.
I guess not Modyne, not Mode Dynamics, but there are Collide, and there's some other things within thinking particles.
Having said that, on Cineversity, I have a tutorial about filling a bottle with pills. It was a bad time. So, and basically what I'm showing is that you can generate your objects using a particle, standard particle emitter, or thinking particles. But then if that MoGraph cloner has a dynamic tag, then the MoGraph dynamics take over the object. So if you're generating something using thinking particles, you can transfer, you can leave the generation up to the thinking particles, but all the other control, you can leave it up to MoGraph. So there's a bit of crossover. Now, Cinema 4D, during its development, has ended up having, so thinking particles, Mo Dynamics, soft bodies, cloth, hair dynamics, spline dynamics. We have six dynamic systems in there which don't work with each other. But nonetheless, the data transfer is such where we can use some of the things one thing does with some of the things the other thing does. So if you wanted to create something similar to what I did today, but by using Mo Dynamics, you would actually generate the clones using the p-matter waves, put the cloner with a little icosahedron or a platonic or something like that in multi-instances, and use dynamics on the MoGraph, and use your particle field, your standard particle fields, to create the turbulence. And then these objects are going to collide with each other as well. So you can create something very similar to what I did with collision.
Just using a different system.
A different system. You generate using the same method, but then the control for the turbulence and all that comes with the other particle system. And hopefully we're going to see a lot of improvements on this as we move forward.
Yeah, our developers are very, very busy, and the demands just keep getting more and more. So here's another question, as people are more excited and interested in the particle world that you just introduced them to within Cinema, and that is, can you have the particles pull the color from surface color?
There are ways to do that. One way is when you use p-matter waves, you can generate particles, not their color, but certain parameters of the particles can be set using a texture. And if you apply the same texture on your surface and the same texture on the p-matter waves, you will be able to pick up some of that. Now, there are other ways of doing it. You can use Espresso. This is the question is very good, because it shows that limit where, although you can do it, if you really need it, that's where you need X-particles, because X-particles can do it so much better that if you're going to make at least $800 or $600 from that project where you need this, go buy it and make the investment. Because yes, you can do it, but it is going to end up to be quite slow.
Significant amount of work for what you're getting.
Or it's going to take time to calculate, because then everything needs to be calculated through Espresso, which is single-threaded, and you have to, for every particle point, you need to read its position, then find what is the closest vertex to that, and you have to transfer the colors on the vertices and all that. Now, there may be an easier way, which I can't think of right now, but if you're doing that, that complex particle work, I would say that investing in a plugin is not a bad thing, or, the artist's time is the most valuable thing on the market. Computer time and software and all that, that's cheap. You can, just do stuff. But your personal time, which most people think is the cheapest thing to offer, no, it's the most valuable thing you have, right? And don't forget, every moment that passes, you never get it back, right? Never get it back. So make sure you save time now to enjoy your work and allow.
So spend more time listening to Noseman tutorials. That's what I say. If you're never going to get it back, you might as well invest it in the right place. You might as well invest it. It's a good return.
Like that, yeah. Give yourself the ability to just be creative and do things that make you happy. I like putting things together. That's what makes me happy. And the fact that I can't make nice looking things, but that's a different story.
Yeah,
I don't want to.
We have a whole nother podcast for that. All right, so somebody is wondering if is it possible to change the life or age of a particle coming in from Alembic with particles from another software? So I guess if you're importing an Alembic particle file, is there any control you're getting?
Very, very good question. So this is something I first encountered when years ago we were working on the Houdini engine, and it used a similar approach, loading particles. No, you can't. And the reason is, even if you change it for that particular frame, on the next frame, because the particle is designated, is hard-coded, the value is hard-coded in the Alembic, it's going to actually read the next value. So you may change its color on this frame, and it will pop to that color. The next frame, it won't. So if you want to override colors, what you can do is get whatever data you want from the incoming Alembic and pass it to a new group. So from a group, you read the positions, but that means you have to double up on your particle number. So create a new, so basically you align the positions and you apply new colors on those. So that's where it becomes a bit more complex. But you have to remember, when you're baking or caching something, it's supposed to be a final state. That is what happens. Now, if you don't have an attribute, what I don't know, let's assume you have particles that have life only because they die at some point, and you don't have color. You may be able to assign a color based on their life if they don't have a color already. So there may be some tricks. There's if you go to the Thinking Particles settings little panel, next to the settings it says channels. Now there are some workflows you can do with those channels where you can introduce custom channels into Thinking Particles. But Thinking Particles is extremely, extremely powerful and very, very deep. The only problem is now it's just slow. That's, for me, that's the biggest issue. It's that it's slow,
right,
which it was very fast for its time. So there are ways. That is something I need to look into. If anyone needs any specific help, the best way to do it is create the simplest possible file. So make an Alembic that resembles or is the Alembic you want to use. Hit me on Twitter, ask the question. I'll ask you for a download link. I give it a shot. I reply. If it's negative, I'll reply in private. If it's a positive, I'll reply in public. I need to look good.
All right. Let's see here. Couple more. Important question. The book behind you. People are intrigued. What is this book?
It's called. Oh, I always forget the name. I'll bring it over. Give me a sec.
He'll actually go get the book. See, that's how much we care on this show. We're even showing you things in our house to make sure you're satisfied.
Cosmic Motors, and it's by Daniel Simon, and it has a foreword by Sid Mead, the great Sid Mead.
Oh, I think I've seen that years ago.
It's
an electrophysics.
Fantastic. It's all sketches and 3D cars and all that. It's all.
Oh, I love it.
Let me find a couple of just one page just to show the quality of design. I love books, so let's see if anything's visible here. It's absolutely beautiful. And I would say that if Sid Mead wrote a foreword for anything, I mean, it is brilliant. And I have a fascination with books in general. I just buy books and read 3 at a time. It takes me a long time, though. I don't read a lot. I read a lot of manuals,
Yeah, as you should. All right. So somebody is wondering, will you be able to share and load scene node groups assets with each other?
If we can share assets and all that. All right. I think the question is, if we make assets and groups, if we can share them, that's the purpose of assets. So the process is, you put together a setup that does a particular thing, whatever, just creating a primitive, anything as complex as you want it. You make it into a group, and then you make an asset out of that. And that gives you the possibility to save the asset in your scene. So it's only local to your scene, which means that if you share your scene, you will share the asset. Or you can save it in your preferences globally. So then every time you open up Cinema 4D, you will find that in your assets. Now, funny enough, some of the nodes, I think the Mandelbrot and the Mandelbulb distributions, they're actually assets. A lot of the nodes we have are actually assets. And if you want to find out if something is an asset, you click on it, you go up in the menu where it says assets, and if the edit asset is available to select, you can actually see inside how this was made. So whether you're saving your group or your asset with your scene, or whether you're saving it in a project or a shared repository for your studio, the asset system was developed specifically for the creation of tools with an interface so that you don't have to recreate the setup. You just take it from your list of assets. You can import assets. You can save it as a very specific zip file, which then you can send to someone. And there's a command somewhere that says load database. And you can go to the preferences in the nodes, and you'll see you can add these, and they become part of your Cinema 4D standard node. So yes, the asset system was created for this particular situation. And I think,
very cool.
Yeah, there's a thought to be able to encrypt them so people can sell them. I don't know, that was something that was generally passed as an idea, and I hope this happens, because this is going to open the market for people that want to make their assets and make them safer, so they can either give them out for free so people can't tinker with them, or even sell them. Hopefully that will be a possibility.
Very cool. I think I got some clarification from my tech team wondering, they mean, can you export assets with scene nodes like you can with node materials?
Yeah, the same. That's
same.
It's the same principle. Yeah, you can.
All right. Someone was wondering.
If I didn't understand the question, again, hit me on Twitter and
get some clarification.
Yeah.
All right. Can you add displacement or hair simulation on these particles? I don't know what they mean by.
No, you cannot add hair on particles, because a particle system, the only reason it's so fast and it can handle so many objects is that it saves the minimum amount of information necessary. So essentially, a particle system is a group of positions, if that's what you have, spins, orientations if you have spin, colors if you have color, but the geometry itself just attaches itself on top of that in Redshift in render time. That's why when Redshift, the reason why Redshift can render millions and millions of particles, I think anyone that has XParticles knows that, how fast Redshift can render particles. It's because the geometry itself is generated in render time. So there is nothing for hair to be attached. What you can do, though, is you can trace particles using the tracer or other methods that exist in XParticle and so forth, and then use the hair renderer in Redshift or Cinema 4D to render those lines. But making hairy particles, you can, in theory, do that, but you will need to use a different way of creating your meshes. So the meshes are live when you create them, so there is somewhere for the hair to be set up on. I haven't tried hair with Alembic. I think it's going to work. I'm not absolutely sure, but I think that if you save your generated clones that were attached to particles and you save them as an Alembic, you can use that Alembic file to attach hair on it. Don't take my word for it, but give it a shot.
Try it. Why not?
Yeah.
So here's another question. We'll finish it up. These are the last two. Thank you, guys. These were really great questions. So we definitely we're running out of time. Don't want to use too much because, once again, artist time is the most precious thing. Quote by Noseman. Let's see here. Which has better thinking particles performance, using thinking particle geometry or matrix object? And this is kind of a two-parter. And in the Espresso setup, what are the fun nodes to connect to the PPAS node like pForce? So the first part is better performance using TP geometry or matrix object, and then some of the fun nodes like pForce.
Yeah, so in the way I've measured it, it's better to use a cloner with multi-instances. And the reason is 20 years apart of technology. So because
very easy.
When we were at render instances, I think it was on par. Even hair sometimes had the ability to create more clones. It was quite optimized. But now with multi-instances, I think that generating the particles and using MoGraph is better. The problem is that you lose some of the data. You can't transfer the color. So in that particular case, and I'm not aware, I'm not 100% sure, but you don't get the P color. Anyway, I may be wrong. That's something I need to test now. You've triggered my right.
You guys are getting them creative.
It's a pen. It's got ink inside, and you write on paper. It's actually made of wood sometimes. So let me
call that analog technology.
Yep, P color to MoGraph. I need to check.
And you talked about that a little bit before, as far as like passing the P group. I know that's something Steve from our tech team has come up. Using cloner object and cloning your P group. So that's
yes,
a way to be able to get that into MoGraph.
Getting the P color, the particle color, I'm not absolutely sure, because if that's a limitation, then you don't have another recourse other than using the geometry, the thingy particle P geometry node, unfortunately, because that retains the color.
Awesome. Let's dive in. So you'll test that out, and I'm sure you'll share that. So stay tuned. Follow Noseman if you're not already. Just at noseman.org. Are you .net? Where's your?
No, I'm not. At NosemanGR.
At NosemanGR on the Twitter and on the Instagram.
At NosemanGR. I don't tweet Instagram, whatever it's called. It's a verb.
So all the Twitters.
No, you can go. You can follow me on Instagram. I mean, everyone's doing it, and I have one post that says I'm switching from one account to the other. That's my own post. But yeah, follow me anyway. I mean, I want to break the record of someone that does not post on Instagram with the largest followers. Oh, and if that fine Japanese gentleman that has the Twitter at Noseman with the guy that has 11 followers since 2007, if you may release that, that would be great. No.
Just hit you up and work out that trade. Last but not least, and this is important. We started with this a little bit, but why don't we dive into those specs? Because everybody needs to know. That's the most important part. This is how we make stuff. What are the specs on the machine you're working with?
Okay, so it's a Precision 30. Let me see. Look at my notes here. So it's a Dell Precision 3640. It has an RTX 5000 that has 16 gigs of RAM. That's the advantage over the 11 gigs of the 2080. It's a mini ATX, small form factor. I think 64 gigs of RAM and some obscure 8-core Xeon inside. And honestly, I come from the world of a 2010 Mac Pro 12-core, which it's still on. It hasn't turned off pretty much a lot. It only turns off when I go to holidays to Greece every year. Other than that, is pretty much always on. It's been on for 10 years. But as far as quality is concerned, and I haven't had it for a long time, but believe me, I push. I've maxed out I've managed to get a few out of memory because I pushed the RAM up to the requirements, 120 gigs of something. I was doing some experimental particle setups using the nodes, and I think I created too many particles. But anyway, no crash or anything. I just let it sit for 5 minutes. For me, if someone presented this machine to me, I would consider it the viable alternative to the Mac's stability and all that. Now, I'm pretty sure that people can put together their own PCs and water-cooled and all that that are half the price and double the spec. But I'm a professional. I know what I'm talking about. I don't. It's fine if you're a gamer, but having a PC that may crash on you or may have other no. I buy my Amazon, whatever I buy, with extra 2 years of insurance. I pay. I want peace of mind. That's why I'm 120 years old, and look at me. Look at the skin. Like it's.
I know. So good.
Yeah,
moisturizer.
You know me. So I want peace of mind. And honestly, if someone wants a small form factor, a machine that just works, and I do VR, I've got my Oculus Rift, I've got everything cats and dogs connected to it, and it just rolls on. It works. It's very fast for what I wanted to do. So, that's
2 years out, and my machine is kicking, and we have very similar specs.
Yep.
Since the last roadshow, and this has been all over the place in rugged travel, and the performance. I've never complained. It's always gotten the job done. Even, from Redshift to you name it, we've had people presenting all types of stuff.
For me, that's the most important thing, is for your hardware not to let you down. Performance can come, right? But I can't afford it mentally, right? I can't afford it mentally. The fact that, what happened? And that's one of the reasons I was, such an avid Mac supporter for all these years, because that's something you really get in the Apple ecosystem. But unfortunately, performance now, with the new machines, I don't know what's going to happen, how things are going to move forward. But as far as a PC is concerned, this is my little. I'm going to put an Apple logo on it just to.
just to feel classic. So thanks again, brothers, so much for sharing all of your knowledge. Real quick, I'm going to be tossing in some of the stuff that we posted earlier. If you guys haven't seen Noseman's, Twitter, that was posted by Kevin and our social media team. So check that out. I'm posting our upcoming events in December 5th. And if you haven't already, and I know most of you have because you are very good members of our community and nerd family here, definitely go to 3dmotionshow.com and click on sign up. And we will give you all the updates of our upcoming shows and information coming out from the Maxon family. And we are going to be down to our last show of the year coming up in December. So definitely come back, check us out December 9th for a whole new lineup, but sign up so you can get notified. Thanks again to our sponsors, Tool Farm, Unreal, everybody that you see on all of our lovely commercials, Dell for the machine, so you'll be able to see all that. So thanks again for everybody who's been supporting the show. And congratulations and happy birthday once again to both Trapcode and Maxon. 30 years. I can't believe it. Time is flying, but the technology keeps inspiring. So thank you, Noseman, for all that you do. And we will see you guys all November or December 9th. Ciao.
fast and knowledgeable customer service.
Swim on in for incredible deals on software and plugins at Toolfarm.
Join specialist sports production instructor Jason Hare for a series of free webinars, designing and creating statistics-based MOGAT templates for use in Adobe Premiere. Using real-world techniques he developed for the 2018 World Cup and 2019 Rugby World Cup, Jason will show you how to build templates in After Effects, combining Red Giant Universe, custom expressions, essential graphics panel techniques, as well as data-driven graphic workflows. See how to share these templates with Premiere Pro, helping editors achieve more in less time.
MoGraph.com, an online resource for motion graphic artists. Start your week with the MoGraph podcast. Industry news, interviews with your favorite artists, and terrible humor. Watch live shows and interviews from MoGraph events like NAB, SIGGRAPH, Half-Res, and local meetups.
This is exactly what I should be doing.
Our MoGraph Talks feature live demos and motivation from artists all around the world.
Sometimes you gotta make stuff that you're not gonna put on your reel, and I'm not here to judge.
What if Rick and Morty show up for the countdown at midnight? That's where I peaked in life, in my career.
We gotta stop this thing, Rick! It's gonna kill us all!
Hear from the people that create your software, design your render engines, and artists that are changing the face of modern motion graphics.
You get that render done. Yeah, you better frame what?
MoGraph tutorials and online classes will teach you about Cinema 4D, After Effects, as well as other popular software and render engines.
Throw in HDR Studio, take the render settings, pick the HDR, put in a reflection, and gorgeous.
Join the conversation in our live sessions.
Ah, that's so funny! All right, I'm gonna live forever.
Subscribe today and get the latest updates on our YouTube and other social media channels.
Take all your dreams and just do it!
Subscribe to MoGraph.com.